Hi guys, welcome to my YouTube channel. How are you doing? Hope you've been following with my previous videos and tutorials, and hope you've also like and subscribe to my channel. This is very important so that whenever I publish a video or tutorial, you'll be the first person to get to know about it. Okay, so hit the subscribe button. So today I'll be showing you how to dockerize a Spring Boot application. But before we get to that, what then is Docker? Right? Docker is simply is a software platform that enables software developers, software engineers to develop, ship, and run their applications anywhere, literally anywhere, with the help of a container. Also, this my definition begs for another question: what's a container? So if you've been working in a team of developers, QA engineers, basically a team with different colleagues that you have to collaborate with each other, you must have had a situation where one guy uh, pushes his code to Git, and by the time you fetch or pull the code, you find out that the code is not working on your system. Then you reach out to him, guy, what's up? Why is the code not running? He tells you, guy, I don't know what you're talking about. As far as I'm concerned, the code works. It works. It's working on my own system. I'd be like, but I'm not using your system. It's not working on my own system. It tells you, guy, I don't think you are doing something right, right? Either your Tomcat server is not up to date, you may need to install one or two dependencies, and you are tired of installing dependencies all over again for every single project that you're working on, right? You find yourself in this hassle of is working on my system, is not working on my system. So this is what Docker steps in to solve for you. Before the advent of Docker, there have been other solutions like the virtual machines, the VM, that try to solve this problem, though they have their own challenges too. But Docker step in to kind of make this thing easy for developers. How does Docker solve this problem of it's working on my system, it's not working on my system? Docker provides you with a lightweight standalone executable package of your application that contains practically everything you need to run your application, including the code base, the runtime, the libraries, the environment, and all your configuration. So this standalone executable package is what we call a Docker image, And a single running instance of a Docker image is what we call a container. Remember, in my definition, I said Docker helps you to run your code, run your applications anywhere with the help of a container. So a container is simply a running instance of a Docker image, right? Okay, so with that understanding, I'm going to show you practically how to Dockerize a Spring Boot application. So I will head over to start.spring.io to initialize a new Spring Boot uh, application. So I'm just going to put the group name, the artifact name, then I will download and extract. Okay, so I'll just add few dependencies. I'm going to make this implementation very simple. So I'll just add Spring Web, right? Just Spring Web, just to so it's a web application. So I've already added a group name, the artifacts, then is going to be a jar file. That's for our packaging. And I'm going to use Java 17, right? And the language will be Java, and the build tool will be Maven. So it's going to be a Maven project, and the Spring Boot version is Spring Boot 3. So I will go ahead and generate this project and load it on your IDE. Okay, so I've loaded my projects and I've resolved the dependencies. So next step, open your terminal and go to the root of the project. So of what we need to do, we need to create a file which we are going to call docker file. So just do touch docker file if you are on Linux. That will create a file which is going to contain our instruction on Docker. So, so we have it here, Docker file. So the Docker file is where we define all our configuration and instruction to Docker. So I've written some instructions to Docker here, which I'm going to explain one by one. So first is this line 3, where I have from OpenJDK 17. So what we are doing here is that we want to define a base image, right? And the base image for this project is going to contain a Java runtime, Java 17. So basically, Docker allows you to depend on another image that is already that's already running, right? So you have a parent image or a base image, so which your Docker is going to start from. So we are going to use Java OpenJDK 17, right, as our base image, right? So the next one is the one we call label. So label, we are just going to add informations concerning our maintainer. So this, I'm going to add just this email, which is going to be information about the person that is going to maintain this image. So feel free to use your own information. Right, so the next thing we are setting here is the volume, right? Volumes are basically mechanism to persist data generated by the container on the host OS and share directly from the host OS with the container. So one of the most common use cases of volume is to store the log files generated by the container on the local host. So in this our doc file, we created a mount point which is /tmp, because this is where the Spring Boot application creates working directories for Tomcat by default, right? So that's why I specifically use the /tmp, right? Okay, so the next thing is expose 8080. As the name suggests, this instruction basically allows you to expose a certain point to the outside world, and I've chosen port 8080 for this. Next we have is the arg. So this instruction defines a variable with a default value. So you can actually override the value of the variable by passing it in a build time. So this is what we have set as the variable, the target, which we are going to pass in build time. Okay, so that's basically our jar file, right? We are going to pass it in build time when we want to build the project. So the next is add, right? The add instruction is used to copy new file into a Docker image. So basically it's going to add the application jar to the container, and this is the application jar that we are passing on or at build time, right? Once we pass it, then we are going to use it add to copy the jar file right into our container. So that's what we use the add instruction to do. So the next one is the entry point. The entry point, so this is where you configure how your application is executed inside the container, right? So this is basically the instructions I'm going to use to dockerize this Spring Boot application. Like I said, I'm going to keep it very simple. Okay, so the next thing we are going to do is that we want to start building the Docker image. So now that we have our Docker file, so let's build the Docker image for application. But then we need to make sure that we have all the packages, that's the application in form of our jar file, so using Maven. And to be able to do that, we are simply going to do nvn which stands for, is a command for Maven. So we're going to say nvn clean package, right? So I'm just going to run that. So what that is going to do is to package our Maven, right? So everything is working, as you can see from my console. Right, I think everything is fine, right? And we are good to go, right? Everything is fine. So this basically creates a jar file in the target directory of our project. So the next thing we are going to do is to build the Docker image properly. So to do that, I'm going to say Docker build dash T monitor app, which is the name of our app. So this is going to build our app for us. Okay, so yeah, I omitted the full stop here, right? So right now you can see our image is built. It's as that simple as that. It's very simple. So now for us to see the list of all the Docker image on our system, for us to do that, we are just going to do Docker. The command is Docker, sudo Docker. Then we are going to say images, right? So this will list all the Docker images we have on our system. So you can see the one I just created, monitor-app latest. You can see just 25 minutes ago, and it just 490 MB. Right. So now the next thing that we need to do is to run our Docker image. So once you have a Docker image, you can run it like this. So to run it, I'm just going to do sudo Docker. I'm going to do run, then dash p. Then I will map this port 5000 to the port I already exposed, which is 8080. Remember, in our instruction, I expose port 8080. So I'm going to map that 8080 to this port, right? So, and I will hit enter. So this is going to run our, as you can see, our server started Tomcat, started monitor application in 3.447 seconds, right? So just with this, I've been able to run our application. All the environment variable, all the environments, the configurations are all in here, right? So having built and run our Docker image, right? So the next thing we are going to do, I'm going to show you, is how to push your Docker image to the Docker Hub. Right? So for you to do that, you need to first log in into a Docker. So I'll just do Docker login. So first, you need to remember that you must have created a Docker account. For me, I already have a Docker account. So all I did just now is to log in, and I've successfully logged in, right? So if you don't have a Docker account, so you should just come here and Docker sign up, right? So here you come here, then you create or sign up for a Docker account. So just create your username, then your email and a password, then you sign up for an account. This is Docker Hub. So for this project, I'm not going to sign up for an account. I already have one. So I will just proceed by showing you how to push your Docker image into the Docker Hub. So I successfully signed up. So the next thing I'm going to do is to tag the image. So to push a local image to a Docker repository or called a Docker registry, you need to associate the local image with a repository on the Docker registry. So what did I say? You need to associate the local image which we've already built with a repository on the Docker registry. So for us to tag an image, all we need to do is sudo, right? So do docker. So I'll say tag, then the name of our image, which is monitor app, then the username of your account that you just sign up. So then I put slash monitor app, which is the name of our app, then colon. I'm going to do the 0.1 hyphen snapshot, right? So this is how I want to tag the my local repository. So that's done. So the next thing to do is for me to now push this image to the Docker Hub so that someone else can simply pull it and use it with everything all packaged. Remember, standalone is a executable package that you can just run anywhere. So to now push to the Docker registry, I would do Docker push, then the name of your username on Docker Hub, then slash the name of your image monitor app. Now the tag, remember what we did, I tag it to a snapshot dot one hyphen snapshot, right? So it's pushing, as you can see, the push ref to repository docker.io liquacious slash monitor app. So if everything works, right, it's connecting, right, everything is going so fine, pushing and mounting it. Once it's done, we can be able to see it on the Docker Hub, and someone else can be able to pull our Docker image and everything will be fine, and the person can run it locally too, right? So yeah. So our Docker image has been pushed to our Docker hub, and you can see this is it. Is the size, and you can see everything. So I'll just simply go into a Docker Hub and see if I can find this. I'll just simply log in. Yeah, I simply log in. Okay, so yeah, so this is our new Docker image pushed to Docker Hub. You can see it, monitor app, last pushed a minute ago, and you can see it's public, means someone else can basically pull this our image and run it on their own system, and won't have to won't record this hassle of is working on my system or is not working on my system. All dependencies, all runtime environment, the code base has all been packaged into the Docker image, and with a container you can actually run it and everybody will be fine. So That's it on today. Thank you for joining us and stay blessed.